Hey everyone, and welcome back to today's Explainer. Today, we're unpacking a truly fascinating research paper called From Understanding to Resonance, a case study of quantum music and embodied science communication. Now, if you've ever found yourself, just completely struggling to grasp highly abstract concepts, or maybe you felt totally locked out of a technical subject, well, this research might just be the key. It proposes a radical new way to communicate complex science. It's basically saying that learning isn't just about reading textbooks, it's about physically feeling the information.
So it begs the question, how do you teach the unteachable? Because when we think about fields like quantum physics, words like distant, highly technical, and frankly, intimidating usually pop into our heads, right? It's a massive challenge in the world of science communication. We're dealing with concepts that are literally invisible to the naked eye and completely defy our everyday common sense human intuition. So how exactly do you engage a general audience with something so deeply abstract without losing them in the first 5 minutes?
Okay, let's dive into this. Traditionally, science communication is heavily explanation-centered. You know the drill. It focuses on conceptual understanding, it relies on heavy technical language, basically your standard chalkboard and lecture approach. And let's be honest, that can sometimes put people straight to sleep. But the authors of our paper introduced something fresh called embodied science communication. And this approach? It's resonance-driven. It uses immersive art and sensory experiences as its primary tools. So instead of hitting you with hard equations right out of the gate that might just push people away, it starts with sensory resonance to draw you in.
Which brings us to Section 2, Art as an Entry Point, specifically looking at Quantum Fest and Quantum 100.
Now, what's really interesting about this data is the sheer scale. To test this theory out in the real world, researchers looked at 2 live initiatives, Quantum Fest and Quantum 100, held in Japan and Germany, and they saw an absolutely incredible turnout of over 4,000 participants. To put that into perspective, that's enough to pack a massive concert hall, all for public events centered entirely around quantum physics. It proves there is a massive public appetite for complex science. People aren't actually avoiding the science itself, they're avoiding the dry delivery methods. Turns out, when you present complex information in an accessible, highly compelling format, thousands of people will eagerly show up to learn.
So how exactly did they attract all those people? Well, instead of chalkboards, they offered immersive, alternative entry points. They completely bypassed the traditional lectures and brought in music, visual art, and embodied participation. Just imagine transforming the highly abstract principles of quantum mechanics into a rich auditory symphony, or walking through interactive visual displays that actually react to your physical presence. It's like a giant puzzle coming to life. By doing this, they provided a welcoming gateway that absolutely anyone could step through, no matter their prior scientific background.
Now, of course, being rigorous scientists, the authors didn't just throw a cool arts festival and call it a day. They systematically evaluated the true impact in 3 distinct steps. First up, extensive post-event surveys. Second, meticulous analysis of written participant comments. And third, in-depth stakeholder interviews. They were looking for hard, quantifiable proof of what actually happens to the human mind when it experiences science through the medium of art.
All right, let's get into the intellectual meat of the research with Section 4, the 3 dimensions of resonance, unlocking human engagement. From all that carefully collected data, the researchers identified 3 distinct, layered dimensions of resonance. First up is sensory immersion. This is essentially the use of artistic and sensory experiences to successfully reduce psychological barriers to complex topics. Think about that invisible wall of intimidation, that math anxiety or imposter syndrome that hits you when someone mentions quantum entanglement. Actually, scratch that. It's more like a brick wall for most of us. But by replacing a complex lecture with an immersive visual or musical performance, that anxiety just melts away. The sensory experience naturally lowers those psychological defenses, so your mind is safely open to receiving new ideas. Let's move to and see how this builds into the second dimension, collective meaning-making. This goes a step beyond just watching or listening by yourself. It involves embodied, shared participation that allows an audience to physically and socially process scientific concepts together. When you're standing in a room full of people collectively feeling the vibration of quantum-inspired music or moving together through a responsive visual art installation, learning becomes a shared physical event. It totally shifts science from a solitary, purely cerebral task into this communal, embodied experience where we learn from and with each other. It's really powerful.
And the whole shebang finally leads us to the pinnacle of this process, the 3rd dimension, transformative engagement. This is an emerging, deep connection where the audience forms a truly meaningful relationship with the subject matter. Because participants first engaged their senses and then processed that experience collectively with others, they were able to arrive at a profound, personal connection with quantum physics. They weren't just memorizing dry facts. Their actual personal relationship with the science was fundamentally transformed. They genuinely felt connected to it.
Which leads perfectly into our final takeaways in Section 5, a new way to learn beyond conceptual understanding. So the crucial point is that this paradigm shift fundamentally redefines what it means to successfully communicate and engage with science. True success should include how people feel and relate to the topic on a basic human level. This is perfectly captured in a really powerful quote from the researchers. They state that resonance-driven approaches can complement explanation-centered science communication by enabling audiences to form meaningful relationships with science before, alongside, or beyond conceptual understanding. This is huge. Notice those words, before, alongside, or beyond. It means you absolutely do not need to understand the underlying mathematics to feel a deep, valid, and worthwhile connection to the science. Resonance isn't trying to replace the textbook, right? It's just providing a powerful, much-needed companion to it.
And that brings us to a final, slightly provocative question for you. How will you apply resonance to your own learning journey? Next time you're faced with a dense, intimidating subject, maybe don't start by banging your head against a wall of complex text. Try to find the music in it, seek out a visual representation, or discuss the broader ideas in a shared space with friends. I want to challenge you to seek out feeling and experience in your pursuit of complex knowledge. Thanks so much for joining me for this explainer, and hey, always keep looking for that resonance in everything you learn.